In physics, when a fast-moving cue ball strikes a completely static object on the table, that state of perfect equilibrium instantly shatters. Welcome to Week 4. Dr. Nur Ashikin Ahmad Nazri leads this module on Newton's laws of motion. Your objectives for this session are strict: master the definition of force, understand Newton's first law, and solve statics and dynamics problems. These three components form the mechanical foundation required before you attempt any complex physics calculations in this course. We define force strictly as an external influence capable of changing a body's state of motion, its overall size, or its physical dimensions. There are four fundamental forces in nature. For this module, we focus heavily on gravitational force, a field force driven by the attraction between massive bodies. Force is the specific mathematical variable required to disrupt kinematic equilibrium. This brings us to Newton's first law. An object maintains a state of rest or constant velocity unless acted upon by a net force. When a system is balanced, the sum of all net forces equals zero. This diagram illustrates the first law. On top, an opposing friction vector acts horizontally against a moving book, causing its velocity vector to shrink until it stops. Looking below at a frictionless environment with zero net force applied, the velocity vector remains constant. We measure this baseline state of constant motion, or rest, as a scalar quantity called inertia. Acceleration never happens spontaneously. It only occurs when an object's inherent inertia is broken by an external, unbalanced force. Translating these theoretical laws into applied mathematics requires you to isolate specific force types across different physical environments. As outlined in subsection 3.14, you are required to accurately draw and label free body diagrams for vertically hanging objects, objects on horizontal surfaces, and objects on inclines. To execute these diagrams, you must isolate three core forces. First, normal forces, kinetic and static friction, and tension forces. Mastering the first law provides the precise framework you need to calculate the multivariable statics and dynamics problems that come next in this course. Newton's first law explicitly dictates the rules for objects in equilibrium. Your immediate next objective is to apply these principles to accelerating objects by calculating Newton's second law. Review the requirements for free body diagrams thoroughly before proceeding to those calculations.